In Module 1, I'd like to talk about OLAP review. Part of this specific section of the course, first I'd like to discuss OLAP databases, and then we're going to get into some of the terminologies of OLAP. That would be an excellent review if you have forgotten to work with analysis services for a while. And then, of course, at the end, we're going to see a data flow and remember exactly how we get the data from relational database management system and we bring it over into an analytical processing unit. So first, let's talk about the differences between OLTP and OLAP. OLTP stands for Online Transactional Processing, and then OLAP stands for Online Analytical Processing. So of course, we have to understand the differences and understand when to use which one. And later on, I'm going to get into some discussion regarding the OLAP, in which has been designed for fast querying, has been designed for business people in order to go and convert the raw data into a meaningful value so they can basically make a decision on their business. And then, of course, introducing some of the OLAP applications that are available nowadays. I'd like to also demonstrate a small little section in our website that you can go and basically watch some free videos regarding the data warehousing. Also, we have OLAP in SQL Server that basically shows you that this is not the only solution that you can find. There are other vendors that probably have gone and created their own analysis services unit. So let's get started with the databases. OLTP was designed for transactional applications. That means you could have gone and basically add, update, and delete an existing record perhaps. Add a new record, update an existing record, and delete an existing record. This is designed for real-time data acquisition. Perhaps e-commerce website or your basically daily database that you're accessing via your Windows-based application. So it's designed for continuous processing. You can also retrieve data from this specific system, as you know. However, sometimes, since the database is normalized, getting the data that you're looking for requires to create complicated joins. And as you know, joins are not necessarily the best way in order to retrieve the data of the SQL Server just because of performance. I'd just like to show you a small little introduction to online transactional processing. For example, if you switch back to SQL Server here for a second, as you see, part of the SQL Server itself, if I go and try to basically open up Enterprise Manager here, let's take a look at Northwind database as an example. And as you see here, just because of the database schema, you might find yourself find actually lots of tables in there in that database that are pretty much have a complicated relationships with each other. For example, part of the Northwind, if I go to the diagrams, try to create a brand new diagrams and go and add basically all available tables in there. This is the entire database, and you might want to find a lot of tables that are kind of related to each other, and it might be complicated. By the way that you're running a specific SQL statement in there, you might want to find a very complicated join statement in order to get the data. So as you see here, these are all available tables that we have, and some of these tables are kind of related with each other. Let me go and zoom this a little bit more. So basically, if you wanted to go and run a query that gets the data from multiple tables, the first thing SQL Server does is to go and parse these table names and then parse the column names on each SQL Server table, and then finds a relationship. On top of everything else, it will check for your permission, whether or not you have a right to read the information. So as you see, it takes a long time for that query to be processed. So that's why you might want to go and place it in a stored procedure perhaps, and compile it, create the execution plan, and come up with the best performance. Still, you got to go through some join statements in there. Rather than getting the data from multiple tables, it would be, of course, easier to go and create a specific table that has all the information for you. So if you do have such a table, you can have one single location and only parse it one time, and not to be worried about keep parsing the data over and over again. So now, if I go and basically get back to our discussion over here, we talked about basically online transactional processing, and as you know, since the process is continuous, you might as well go and think about denormalization in order to get the data as quick as possible, rather than normalizing the data. Normalization is excellent for data manipulation, data modification. However, for reading the data is not a bad idea to get everything into the same table and query one single object because it's quicker. Well, just because of that, you might necessarily deal with a table that has 2 dimensions but has many columns. Again, that is not a great idea in order to retrieve the data because you might want to go and search so many different columns out of it. But they have come and they designed a system that is analytical. And that means they give you the capability to have more than one dimension. In other words, they don't want to recreate the wheel. They want to use an existing online transactional processing in there and try to get the data from an existing location like online transactional processing and get it into a new analytical system. And using that, you could have multiple dimensions. Because as you know, a regular table has 2 dimensions. You have rows versus columns. But using analytical processing, you might have more than one dimension. And what do we mean by dimension? I'm going to get into it in a minute, but consider a dimension as the way you look at data. For example, in your business, you might want to come into a situation that someone from marketing department asks you a specific question. Could you please create me a query that shows, for example, how much, for example, items we have sold in the past quarter? Someone from accounting department might come and ask you a different question. For example, how much was the total value of the last quarter? Someone from management, higher management, wants to come and see who has sold the most. Someone from, for example, manufacturing department wants to see how much unit do you have on stock. So as you see, every single person in different department in your company, they want a different answer. And if you think about it, they're all looking at the same data but in a different way. So you have to combine different things together in order to get the right answer. After all, everybody goes back to 2 things: how much and how many. If you think about the business, it goes back to the dollar and cent. So the whole core of any cube in data warehousing is always talking about numerical values, either numerical as a dollar amount or numerical as a quantity. And of course, the way that you want to look at that is from different angles. How would you like to take a look at that? The products, the country, the state, the regional location, the time, when did you buy that much, when did you sell that much, and so forth. You see, everything goes back to the numerical values. So that's the core of our cubes, if you want to think about it. But overall, if you want to focus on OLAP databases, we have always a summarized data. We don't get the detailed information. If you want to get the detailed information, you have the capability for it. But you already have that data. You already have it in online transactional processing. So we get the summarized data because we want to know what's the total value on that specific time. And of course, since we have already dealt with an existing data, it's kind of a historical database. That means we don't really change the data whatsoever. We might want to go and change it in like data warehousing. We might want to go and split it up. Maybe there is a mistake. We would like to go and change that perhaps. Maybe companies takeovers and buyouts requires you to go and change a few things in your data warehouse. Maybe, for example, just for an analogy, your company sells a portion and a department of its company. And of course, it sells all the IT with it. So let's say the name of the company has changed, so the brand new company wants to come and change the name of the company in the data warehouse. So in that special occasion, you might want to go and change the data warehouse value, but most of the time, you're not going to change anything in the data warehouse. You just want to read the information. So that's what we look at as kind of a read-only database. We just want to read the data. So that's why online analytical processing was designed in an environment that is heavily indexed. SQL Server analysis services automatically provides that technology for you by creating a cube and processing the cube and creating dimensions. Obviously, you're making a special type of database. And then, of course, you have a specific processing cycle. And this processing cycle really depends on the business itself. Always, OLTP can be the source of your OLAP databases. Of course, you could also have OLAP database to get its information from any other relational database management system, as well as your analytical systems. So if you wanted to think about OLAP once again, you could consider that is designed for reporting and analysis. You have an intuitive model, you have a drill down and drill up capabilities that you can actually go further down into a detail of a specific event, and then of course you have the slice and dice capability. You can only see a portion of the data rather than the entire data. It is fast and flexible because Microsoft uses internal engines and services in order to take advantage of that. As far as the applications that are available, if you wanted to really get into the detail of it, every single business, no matter what is the size, how big they are using the OLAP applications anyways. However, they might not utilize it the way that they should. If you think about it, in any business you got some executives that they make decisions. So like performance measures, like exception reporting and so forth. These are kind of an application that answers the questions to executives. Any company deals with the money, so you have financial people. You might want to go and report, plan, and do the analysis on the budgets, for example. There are some other examples about OLAP. As far as the operations, manufacturing, you want to find out what's the part that fails the most, what's the part that has been sold the most. As far as the customer service, what are the errors that people are, reporting? Like, is there a common problem with a particular product that the company sells, for example? You might want to go out and use that kind of analysis services in those kind of environment. Product cost, total cost of ownership perhaps. Sales marketing application like booking, billing, product analysis, customer analysis. These are some examples that are using OLAP internally. Again, you could combine them all into one simple or custom solution, part of your own company. So OLAP is a very powerful engine that allows you to answer many of your questions, part of the business. In other words, you're converting the raw data into a meaningful format. A raw data located within the relational database management system. For example, you say product A, we have 5 units of it, and it costs, for example, $3 per unit. Versus analysis services says how this product benefits your company. In other words, how much of it has been sold in the state of Nevada, for the sake of discussion, at what time, by whom. So you could actually answer all these questions and place it within one temporary location or permanent location and have it to be queried over and over again by many different people. So OLAP is not necessarily a Microsoft solution. There are many different vendors available that they have already created that engine. OLAP has been around for a while, and there are some companies that they create proprietary tools for their own OLAP services. However, Microsoft is one of the several vendors. Analysis services is bundled with Microsoft. So if you wanted to get that, you have to buy SQL Server. And the installation of it is separate. As you are familiar with SQL Server 2000 perhaps, you can run many different instances of SQL Server on the same box. Up to 16 different instances if you have Enterprise Edition. However, there is only one instance of analysis services. You cannot have more than one server, analysis server on the same box. So you should consider that, just in case if you're going to deploy analysis services for different companies. Imagine you have, for example, a company like a data warehouse or data center that would like to host many different servers on their box. You cannot have more than one analysis services on one machine. Part of the OLAP itself, analysis services has one specific service that includes 2 different engines. You have the OLAP engine, which takes care of the analytical processing, and then you have data mining technology. The data mining technology allows you to find patterns, allows you to find similarities between data. Consider the fact that you're working for example, an insurance company. Let's say you have some cases already, and based on your existing customers' portfolio, you already know exactly, who's your customers. In other words, you have basically gold customers, silver customers, and bronze customer, for example. Somebody, pays its due on time, they have good insurance, they never claimed anything, and so forth. There are some customers that have caused probably some claims. So by the time a new applicant comes and wants to get an insurance, based on that new person's portfolio, it's not a bad idea to go check that against a specific pattern to see where that customer leads to. Or like getting a loan from a bank. The way that they approve someone is based on the history of the past and similarities of that person with their information. So they're comparing the new value against an existing pattern. So in order to find that pattern, you have to come up with a formula. Data warehousing classes teach you that. We have like two major one of them. We have the decision tree versus the affinity grouping. So there are so many things that we can talk about data warehousing, but we assume that you already have that knowledge. But here, the data mining technology, just consider the fact that allows you to find patterns based on an existing formula. And you don't have to design the formula. Analysis Services has that specific interface that asks you some questions, tells you what are the inputs and what would be the output. So based on that, they can find the pattern for you. Microsoft has hired a bunch of PhDs, and they've already figured out that specific formula for you. All you need to do, go through the wizard, answer some questions, and there you have your pattern. And based on an existing pattern, you can check that against your new data. So of course, course 2074, it actually gets into the detail of it. As far as the OLAP definitions, we have some vocabularies in here that I'd like to get into. We got dimensions and hierarchies, we got the hierarchy organization, and then we're going to get into OLAP family relationships, and as well as the cube itself. If you wanted to take a look at the dimensions and hierarchies, consider that dimensions allow you to slice data. Like for example, if you're considering time, you want to find out when specific data was available. So for example, if you consider a year itself can be divided into 12 months. So each specific month is a slice of the time dimension, if you think about it. And each, for example, month could be a slice further down. Like for example, you could divide it by days. Each day could be divided by hours. Each hour could be divided by minutes, and so forth. So that's an example of a slicing data. In the case of products, you could perhaps break it down by different categories. You could break it down by product type, product category, product range of pricing, so many things. You could actually customize that the way you want it. Again, course 2074 teaches you how to create dimensions and levels within the dimension itself. So allows you to slice. For the sake of discussion in here, I have a product dimension. I can slice it and only look for a certain product, as you see, like Colony muffins. You could also dice it, and what does that mean? Dicing means that you could see the intersection of two different slices together. For example, if you're looking at the data by looking at it in two different dimensions, you could actually find the intersection between those two dimensions and find a specific unit. In this scenario, you could, for example, find a specific product category and see its value on a specific country. So if you have two slices that they meet somewhere in the intersection, that's dicing. Slicing versus dicing. So you slice one dimension, and then when you merge them together with another dimension on a unit that they actually match, that would be dicing. This is an excellent opportunity for you to see OLAP. Once again, as you see here, we got already calculated all the possible answers, and we store it within the cube. So by the time a business manager comes, a business analyst comes and wants to find a particular answer, like for example wants to see how much meat have been sold in Mexico, for example, you can just see the answer right away. You don't have to go parse it anymore. You don't have to go search for it anymore. Has been already calculated, has been already processed, and you stored it within a cube. So all they need to do, rotate the dimension, say which dimension they want to have the value on, and rotate it, find a particular cell, and there you have the answer. So that's why online analytical processing has been designed for fast queries. Now you could basically go and hierarchize your dimension, and that way you could create categories, drill down, drill up, and basically get the data the way you want it. In other words, navigate between different levels. Now let's talk about some of the vocabularies in here. If you have a dimension, by default Microsoft gives you one hierarchy, and that would be all dimension. That means you have one dimension and you have all members within it. However, you might want to go and break it down into smaller categories or subcategories perhaps. As I mentioned, Microsoft automatically gives you the all members. You cannot delete that, you cannot destroy that. You could rename it, you could perhaps go and hide it if you don't want to show it. That's totally up to you. However, you cannot get rid of it. There are other available categories that you can go and add. And basically, why do you want to categorize? Because you want to just basically group certain members based on a particular criteria. For example, consider all available countries that you're dealing with. You could categorize them by a region. For example, North American countries, South American countries, or perhaps you could, go and categorize them by the language they speak. For example, English spoken language, countries like British, United States, maybe a portion of Canada. You could actually go and categorize the countries the way it makes more sense. Again, these are going back to 2074 class, and the way that you design your levels and the way that you design the hierarchy really goes back to the queries that your customers or end users are looking for. Then, of course, as I mentioned, countries, you can create a country level and then have members within it. As you see, the popsicle icon in here indicates a member within that level. And then this is the default level, as you see, a blank square, and then you have filled up a rectangle actually, and then basically based on that you could find out what level are you in. This is the first level, this is the second level, and so forth. As far as the relationship between OLAP's dimensions and basically the OLAP levels within a dimension, we have some terminologies as well that I'd like to focus on. As you see, USA is basically a dimension and is a parent. These are the keywords, and it's extremely important to pay attention to these keywords because we are using them within MDX. There are functions within MDX that we are going to use throughout the rest of this course, and they're referring to the same relationships that we have. So USA is the parent of Northwest and Southwest. So as you see, the Northwest and Southwest, they are both children of the United States of America. So as you see, the parent and children already expose themselves as two functions of MDX. So we could actually take advantage of it. We could use the children and pass parameters to it and get the actual value. So I'd like you to visualize what we're talking about right now. So by the time we talk about MDX expressions and queries, at least there are no strange words for you. As far as the California, as you see, they are descendants of the USA. Well, children is a immediate children. Descendants is kind of a children, but is a child of your child. So if you think about it, both Northwest and California are descendants of USA anyways. Descendants is a more generic term as being a child. If you think about it, your child is your descendant anyways, but is your immediate descendant. That's what we are distinguishing and calling it children or child, versus your, children's child, which becomes your descendants. The same story is true. So both of them can get the same value to you. Also, Washington and Northwest, they both have the same ancestor, which is the United States of America. Your immediate ancestor becomes your parent, if you think about it. The same story is true in here. Then you have Northwest and Southwest. They are siblings. And then you have basically Oregon and California, which are cousins. If you think about it, they're coming from two different parents. So we call them cousins, rather than having the siblings, which have the same exact parent. USA is the parent for both Northwest and Southwest. And if you think about it, Oregon and California, they're coming from two different immediate parents. So we know them as cousins. And then, of course, all are dimension members. In other words, no matter where you are, who's your parent, you are a member of that specific dimension. In the case of humanity, if you think about it, we talked about cousins and siblings and all, we are all human. So no matter who's sibling or, parent or child and so forth, we are all human. So we could be part of the human race. As far as the cube organization, as long as you're dealing with multiple dimensions and you're relating these dimensions together, part of the same cube, then you're dealing with numerical values, as I said. Everything goes back to dollar and cent, as I said. You are thinking about how many, how much. So if you think about that, in this scenario, we have a cube which consists of more than one dimension. How many dimensions do you see at the moment? You have the country's dimension in here, in my right hand side. You see the product at the bottom, and then you see the sales and dollars unit. So how many dimensions really? Country versus product. You got two dimensions if you think about it. However, you got the sales dollars and sales units. That means that the dollar amount and the unit itself has been already calculated on the intersection of each dimension. So by the time you processed your cube, you have already found Canada and you found bread, and you calculated, and it became 1046. Then you found Canada and dairy, and then you calculated, it became 1884. You did that for every single dimension and every single level of that dimension, and you calculated. They call it the cube processing, which again we are talking about a lot more in course 2074. So if you wanted to think about that data flow, the way it works, you got the OLTP systems, which are basically your relational database management system. You're creating your data warehouse, and basically using the data warehouse technology, you're creating some cubes, you're populating the data right out of the OLTP system, and then of course the data warehouse might consist of one or more cubes, and then the client accesses the OLAP cubes using the MDX. Just for information, there are courses related to OLTP, course 2071, 2072, and 2073. They are teaching you basically OLTP systems, SQL Server administrations, implementations, as well as the language itself. Course 2074 and course 92, these two courses teach you how to create the data warehouse, how to create the cube, and how to populate the data in there. Course 2093 basically teaches you how to work with MDX. So that's the way, that's the flow that it goes. So we already assume that you already know how to create the cube, how to populate the data, and how to have the data warehouse. This course only focuses on MDX. So as you see, we're already working with an existing data warehouse. If you are taking this class and you have not created your data warehouse, obviously you're going to go back and learn more about data warehousing. So in order to work with an MDX, you have to have a data warehouse that has been already populated. So what I'd like to show you is basically the market database. The market database is a sample database that we are going to work with, and the way that I like to deal with this specific market database is to show you where you can find it. Part of this specific training, you get basically a setup that allows you to set up your labs. We have already done that on your machine in here, and as you see, we got the MOC, stands for Microsoft Official Curriculum, course 2093, and then of course you got some batches. This is the market cabinet file, and as you see, this is a database. So the way that we want to work with this, we like to go and basically open up our analysis services, and by launching the analysis services manager, we can actually go and, let's say, connect to our analysis services itself in here. Let's call, for example, London. In my case, you have to actually just connect to the computer name that you're dealing with, and then as you see here, I can go and restore basically a database. If I wanted to restore a database, that comes basically from my C drive, MOC, and then on the batches I have the market cabinet file. I like to restore this particular database, and because most of our demonstration will be based on the market, a specific database in here. So if I go and expand this market database, as you see, I like to demonstrate a few things in here. First of all, the data source has been already set for me. I can actually go and edit that. As you see, it's pointing to the MDB or Access database, which is located under lab files 2093 mock. I can test the connection to make sure that it's working. They have already created 3 major cubes for us, a couple of virtual cubes for us, and basically these are all available dimensions that you're dealing with. I like to demonstrate a few things in here. We don't have any mining model. That's outside of the scope of this class. That will be part of course 2074. And then of course we don't talk about security either. We talk a little bit about security later on, perhaps, just to show you how you can set that up. However, these two are being discussed mostly in course 2074. I'd like to introduce these cubes to you. You have the sales cube, which we are going to use that throughout most of the chapters in this class. We have the sales budget. Basically, sales budget is the cube that we are working with it mostly in chapter 8 of this class. Actual and budget is a virtual cube that combines basically the sales budget as well as the sales cube. again, we are using that in Chapter 8 as well. So these two are the primary focus for Chapter 8, or our case study. We are going to deal with that. Also, we have the finance cube, which we are dealing with it for Module 9, which is the calculated cell. What I'd like to show you is basically open up the cells, and I'd like to show you the metadata for this particular cube. As you see, the metadata for this particular cube shows that you're connected to this particular market database. And if I expand this in here, let's actually go and take a look at the metadata. I think the metadata in here, it doesn't work as well. It should show you all available dimensions in here. What I'd like to do, let's go ahead and close this analysis services and reopen it. Hopefully that will do it. So as you see now, the metadata appears. If I click on the sales cube, it shows all available dimensions that have been used. Part of that is specific cube. It shows whether or not you have the shared dimension or private dimension. It shows available measures in there, whether or not you have calculated members, whether or not you have calculated cells, and so forth. If you really want to learn the entire analysis services, analysis server, and how to create dimensions, how to create measures, how to create perhaps calculated members, and so forth, course 2074 would be the class for you. We are focusing on calculated members using MDX in this class. Also, I'd like to talk about the state dimension in here. As you see, a state dimension has geographically broken down the data into different categories. We've got the product dimension in here that again has, based on category, subcategory, and product name, you can actually see all this information in here as well. So these are available levels within that dimension. You can actually see the time, which has a hierarchical dimension. You can look at the time in two different ways. As you see, it's the same exact dimension, but you're looking at it two different ways. In other words, the start time is different. Like any other company, you have the calendar, which starts from January 1st, or you might have fiscal year, which perhaps your company has started not necessarily from January 1st, from any other date. So you can actually take a look at these two differently. Each specific cube might have one or more dimensions, as you see. So these are available dimensions that we're dealing with, and these are available measures that we have in each specific cube. So part of this particular cubes, we could actually browse the data either by right-clicking at it and saying browse data, or you could click on data itself, and that would have automatically launched the pivot table that is available part of analysis services, and you could actually test the water and see how the cube really shows its data. You could also take a look at each dimension and look at the categories and the product itself, and you see the data will change accordingly. For the sake of discussion, you can see colony bagels at all time on the fourth quarter of fiscal time, and all the states have been, for example, 25.74. And if I go and only show it for Northwest Oregon, there is no sale for them. For California, there is no sale for them. Northwest, they have some information in there as a total, as you see, but you don't have any specific value for the quarter 4. So let's go and change that for the entire year, and as you see, again, it wouldn't make any difference. So that would be for Washington in 1997 actually, that's the value for it. So you could change basically the dimension and get the different results that way without even going any further to any other third-party application. Also, sometimes you might want to deal with a particular value. If I go, for example, with the specific dimension in here, if I go to the edit, as you see, the editor comes along, and if I wanted to take a look at the data, and if I click on some of these particular variables, you might see a member property in here. And as you see, there is no member property for this particular dimension. Let's go and change basically the editor, and as you see, if I click on data, you might as well find some of these values have a member property. So the concept of a member property is to get the data from another location and relate that with this specific level. So as you see, the bagels have a manager called Sherinomer. So like Great Bagels has a price of 186. So the member property is another technique, another way in order to go and basically relate dimensions together. There are many different reasons that we go with member properties. One of the way that we're going to go with member property, one of the requirements of creating like virtual dimensions is create a member property. In other words, you don't want to have a column in a table. You would like to use an existing column of a table in order to treat it like a dimension. Then you need to go with a member property. Again, these are the concept comes from 2074 class, and the reason I'm talking about is to review what we have talked about before in other courses, and we expect you to know those information. So let's switch back here to our discussion over here, and let's see what we have talked about so far. We actually talked about basically the databases. We talked about the comparison between OLTP and OLAP. We actually discussed some of the applications, some of the reporting technologies, and of course we talked about the cube organization and so forth, and the data flow as well. So the market database was exposed to you. The rest of the course, basically, there are some labs and also some talks regarding the MDX and specifically this particular market database. So we basically finished the first chapter of this course, 2093, and as you see, we discussed OLAP databases. We compared them against OLTP. We talked some of the terminologies. We talked about the terminologies and definitions of OLAP, and also I showed you the warehouse data flow.